Hello everyone, how are you? I'm Dhaatrik Chowdhury. Welcome to my YouTube channel, and today we'll be learning a new concept, that is frame of reference. We'll be learning this part in details, and I'll be discussing about the types also. So before we get started, I need to draw a diagram so that you can understand this concept very well. So we'll be back within a snap. So we're back with the diagram. What you can see over here is there are three persons, person A, person B and person C. Person A is at rest. That means it has a velocity which is equals to 0, or we can say the speed is also equal to 0. That means it's not moving with respect to its surrounding. The next is a person B, which is on a car. Okay, the car is moving with a velocity of 30 meter per second in the right direction. This is my right direction, so in the right direction. And there is another person C, which is on a plane, on an aeroplane, which is moving with a velocity of 250 meter per second to the left of my direction, to the left of me, not my direction, to the left of me. Okay, so by the way, this B and C, I know this is not a realistic kind of diagram, but in this way you can understand this concept better. For that reason, I have been drawing in this way. What we'll be doing now, I will place myself in the position of A, B and C. Then we will try to visualize that if I am at the position of person A, then I will try to visualize that in what way B is moving and C is moving. And respectively, I will be doing that for B and C also. Okay, so let's get started. I'll be writing the first case as POV of A. POV of A, and the second we will be doing is, and the second we'll be doing is POV of B, and third is POV of C. Okay, why POV? In Gen Z style, means in today's generation, what does POV mean? The point of vision or point of view. For example, like if there is some situation that has happened or some event or some incident, we have our own opinion, right? That is our point of vision, the way we see it, right? This is the same for this also. The way I'll be seeing when I will place myself in the position of A, in the position of B and in the position of C. So first let's start with position of my POV of A. For POV of A, you can see that person A is at rest. So velocity of A will be 0 meter per second. He is already at rest, or she. There, that person is already at rest, right? So it will be 0 meter per second. I am in that position. So what I will be saying? I'll be saying that the car is moving to my right with a velocity of 30 meter per second. So the velocity of person B with respect to A will be 30 meter per second towards the right. I will just denote it like this. Okay, all of them are vectors. Okay, so and what will be VC, the velocity of C? The velocity of C, what I will see, that the velocity of the plane is 250 meter per second, which is moving in the direction to the left, right? So 250 meter per second to the left. This part is very easy. For point of vision of A, this is very easy. But let us start with B. B will be a bit more complicated. So now I am at the position of B. I am in the moving car. Okay, I am sitting in the car. First, let us visualize a thing that when we are sitting in a car, or let us say when we are in a bus, we guys are standing or sitting, right? That means we are at a position of rest with respect to the inner surrounding of the bus or the car, right? That means with respect to the bus, we are not moving. Okay, so In that way, VB will be 0 meter per second with respect to the inner side of the car or the bus, right? Inside the bus, we don't loiter around, we don't jump. Do we do that kind of thing? No, right? So the velocity of B inside the car will be 0 meter per second. But what I'll be seeing, now I'll be observing person A or any stationary object outside the car or outside the window of the bus, like let us say a bus stop or a tree or a building, anything. What I will see that if I am moving in this direction, if I am moving in this direction, I am moving in this way, then all the surrounding outside the car or outside the bus will move in that direction, in the opposite direction, right? That will appear to move. Those are stationary things, but those will appear to move in the opposite directions, right? That means if I am moving to the right, then all the surroundings will be moving to my left. If I am moving towards you, then everything surrounding me outside the bus or outside the car will be moving in the backward direction, right? So, velocity of A will be in the direction to the right as I am, to the left as I am moving to the right, okay? This is the direction. Now, what will be the velocity? The velocity will be same as that of the car. We are moving with a velocity of 30 meter per second in this direction. So, what I will see? The all surrounding are moving with a velocity of 30 meter per second to the right, to the left of me, right? So, this will be nothing but 30 meter per second. Now, let us come to the part of C, the person C. What will be the velocity of person C? See, we know that the direction, it is in the right or it is in the left. So, the ultimate direction of the plane will be in the left only. It is moving in the left, right? So, this plane has a velocity of 250 meter per second to the left, right? But when I am moving to the right with the velocity of 30 meter per second, then I will be saying that the plane is moving even faster plus the velocity of that of the car, right? So, we will add this with the velocity of 30 meter per second in the right, okay? In the left. So, now the total will be 280 meter per second to the left. I hope you guys understood this much. Next, we will be moving to the part of C. What we will be seeing for C? See, when I am in a plane, when I am in an aeroplane, I don't dance, I don't move, I don't walk. What do? We just sit. We just sit quietly. We enjoy the view, right? That means with respect to the surrounding inside the plane, I am at a state of rest. For that reason, VC will be 0 meter per second with respect to the inner surrounding, right? But what I will see? What I will see for person A? I am moving to the left. What I will see? Anything that is stationary, that is moving to the right of me, right? In the opposite direction. So, VA will be in this direction to the right of me. With what velocity? With the velocity of the plane, that is 250 meter per second. Okay. Now, let us come to the velocity of B. Velocity of B, I am writing this over here. Okay. There is no enough space over there. So, velocity of B. The B is moving with a velocity of 50 meter per second, 30 meter per second to the right. Already it is moving to the right. So, 30 meter per second to the right. That means the velocity of the plane will be added to the velocity of the car. So, 250 meter per second in the right, So total will be 280 meter per second. I hope you guys understood this much well. This means that the point of visions are unique. The point of vision of A, point of vision of B and point of vision of C are different. The way we are saying this thing are different, right? But this doesn't mean that the point of visions cannot be same. This can be same. In which way? If both the person are in the same place, are in the same kind of situation. Let us say there is a person, person D, which is also over here. That means POV means for D, it will be same that it is at rest just like the C. So VC will be 0 meter per second. Sorry, this will be VD. And this thing, the way he will see the person A will be moving or the way person B will appear to move will be this only, right? So in this way, if both the persons are in the same frame of reference, now this is the frame of reference. This is the frame of reference and this is the frame of reference. That means the frame of reference can be any living body or any non-living body. I can be a frame of reference, right? Any tree can be a frame of reference. Any bus can be a frame of reference. An aeroplane can be a frame of reference, right? So either living or non-living, anything can be a frame of reference. Now I will be discussing about the types of frame of references. There are two types of frame of reference. The first one is inertial frame of reference. So let us write over here. Inertial, okay, frame of reference I am writing for. Frame of reference. The first one is inertial frame of reference and the next one is non-inertial frame of reference. Okay. So there are two types of frame of reference. Inertial frame of reference is the frame of reference which follows the Newton's laws of motion. We can write over here then follows NLM, Newton's laws of motion. Especially the first law of motion. What is the first law of Newton? The first law of Newton states that if a body is at rest or at motion, it will be at a rest or at a state of motion in the same direction until and unless an external force is applied to it or any kind of force is applied to it. This is also termed as a law of inertia, right? This is also called the law of inertia, right? The second thing that it follows or the second criteria that must be followed to be in an inertial frame of reference, that is the body must have a acceleration 0 and the velocity must be constant. That means the velocity is not changing. The direction is also not changing. In that moment, we can say the frame of reference is an inertial frame of reference. For example, I told you three kind of things: a plane, a car and a human being, right? When a plane is moving with 0 acceleration, that is, it's moving like this in the same direction with a constant velocity, then it is at a frame of reference. When a car is moving in the same direction with a constant velocity with 0 acceleration, then it will be considered as a frame of reference. Okay. For non-inertial frame of reference, it is just the opposite of that of the inertial frame of reference. That means it doesn't follow the NLM. It doesn't follow the, or we can say it doesn't obey the Newton's laws of motion. The second criteria is acceleration is not equal to 0 and V is not constant. That means V is changing. V is changing. For example, we can say when the plane is taking off, it is accelerating in that direction, like towards the sky. That means the direction is changing, the velocity is changing and it has an acceleration. In that moment, it is considered as an inertial frame of reference. That means that any body can be expressed as inertial frame of reference as well as non-inertial frame of reference if they satisfy those conditions in some point of time. If the plane is moving in the straight line with zero acceleration with constant velocity, then it will be an inertial frame of reference. If the plane is taking off, then it will act as a non-inertial frame of reference. Now you all must have, okay, there is another example also, merry-go-round. This is a kind of play that we used to play when we are kid. So this is also another example. So we all might have one question that if Earth is an inertial frame of reference or non-inertial frame of reference. In some of the books you will find that Earth is a non-inertial frame of reference or it's a inertial frame of reference. But what's the real truth? Is it inertial one or the non-inertial one? For that, I must say that Earth has two kinds of motion, right? How? First, the Earth revolves around its axis, right? It is revolving around its axis, right? So it has a axial motion, right? And as well as it is moving around an orbit in an orbital path around the sun. So it has an orbital motion also, right? So it has two kinds of motion and it has an acceleration, right? But the thing is that when we are doing experiments inside the Earth, when we are calculating some value, when we are doing something, when we are considering something, some body inside the Earth as a frame of reference, then that can be considered as a inertial frame of reference. Why? At that moment, the acceleration of Earth can be considered as negligible. That means nearly equal to 0 meter per second square. That's why inertial frame of reference when we are considering when we are doing some kind of experiments inside the Earth. Okay. And when it is non-inertial frame of reference, for non-inertial frame of reference, we can say when we are doing some astronomical calculations, like we are doing calculations, we are doing experiments with heavenly bodies like some satellites, some other planets, like with some sun, so not some sun, with the sun, right? So in those scenarios, the Earth has an acceleration that is also very small acceleration, but that has a bigger impact on the calculations. For that reason, Earth is considered as a non-inertial frame of reference and the acceleration is about 0.006 meter per second square. Okay. This is only for astronomical purpose, or we can say astronomy. For astronomy, the Earth is considered as a non-inertial frame of reference. Okay. See, we can find this mathematically, like full with workout problems and everything with derivations and all. But for that reason, you must know angular velocity, centripetal acceleration, solid angle. So as soon as I complete those parts, I'll be explaining this again, that why it is a non-inertial frame of reference, and I'll be proving this mathematically. And why it's a inertial frame of reference, that also I'll be proving with a mathematical proof, with a mathematical derivations. Okay. So for today's class, this is it. And I'll be back with another video within some days. So keep smiling, take care, and what? Tata.